Hello grade 12, I hope you're doing well. So if you tried solving the exercise 17, you notice that, of course, the reaction is between the base, sodium hydroxide, and the acid, hydrochloric acid. Both have the same concentration of 0.01 moles per liter each. Now we have 50 milliliters of the base. So these 50 milliliters will be neutralized exactly with 50 milliliters of the acid. So in this case, 50 milliliters of hydrochloric acid, the resulting pH, the resulting solution will be neutral and the resulting pH will be 7. Because if we write the reaction, H3O plus HO minus gives 2H2O, the reactants will be in stoichiometric proportions and will react completely. If we have 10 and 30 milliliters of the acid, the base, the solution will be basic, because in this case the 10 mils of the acid will react with 10 mils of the base. And then we are left with 40 milliliters of the base, sodium hydroxide, that we can use to find the pH. In this case, 100 milliliters of hydrochloric acid, of course the solution will be acid and the pH will be below 7. So in this week I ask you to try solving exercises 18 and 19. And hopefully next week we will move on to the next chapter. In these exercises, what you need is first to plot curves of pH in function of volumes. So here VA, the volume of the acid. So we have the acid in the burette, the base in the beaker, and the pH meter is giving us the pH with each milliliters of the acid. And then use the method of parallel tangents that we explained in class to try to find the equivalence point. C, determine the pH at the equivalence point. So you may suppose that the pH at equivalence point is 7, and you are right, because we are dealing in this chapter with strong acids and strong bases. So when both species are strong, the pH at equivalence is always equal to 7. However, this will not be the case for the next chapters. This is why in this chapter we will practice actually this graphical method, but it's not really important because we already know the equivalent pH, or pH of equivalence. However, it will be useful in the next chapters. In part D, calculate the concentration of the basic solution. So here we have CAVA equals CBVB, and you have 3 of them and you find the 4th one. Exercise 19 is very similar, however here you have the graph. And the questions are which of the solutions is placed in the beaker and which fills the burette. And to know this, you need to look, of course, at the graph and the axis. Determine graphically the equivalence point, so you can do this on the book. Find the pH at the equivalence point. Write the equation of the reaction involved. So the equation of the reaction is the only reaction that we studied in this chapter, because there is only one when we are talking about strong acids and strong bases. The one that I mentioned in exercise 17. If the concentration of nitric acid, so here they're giving us some numbers and we need to find the missing term. Good luck.